I might forget to start later on. All right. So yeah. So basically, what we did was we we downloaded this particular Hadoop version, which was suitable for CentOS and on particular version of 2.4, Hadoop 2.4. So we downloaded that, we extracted it, and then we moved this folder to user lib, and afterward we basically linked it. So effectively we have this after unzipping, we have put it in user lib and Spark. Under that folder there is PySpark. You can directly run it. Okay. If you just extract it and go to bin folder and run PySpark, you should see a command prompt. All right. And from the command prompt, you can just start the you know work. Or we have already done the installation. You can go to log in as a student and run it. So you will see the command prompt, and from there you can start your work. All right. In the Cloud Labs itself. All right. So Santana's question is, what are the different levels of opportunity in this technology, like MapReduce programmer, administrator, etc. So yeah. So there will be a position called Hadoop developer, and there would be another position called Hadoop cluster manager or Hadoop administrator. All right. So, and then there will be third level would be analytics. So people who know how to install Hadoop, people who are good with Linux and good with Linux administration would be appropriate for becoming Hadoop administrator. And Hadoop developer would be those people who can write a little bit of code to run MapReduce and to basically run a workflow of various things. They can import data, they can even run pig queries. So somebody who knows end-to-end things would be a person who is suitable for big data development or Hadoop development. Okay. So this course, what we are currently doing is big data and Hadoop development course. Okay. This is most exhaustive course, and this is suitable for somebody who is looking out for a hands-on kind of opportunity. Okay. And yeah. And third one would be analytics. In analytics, there are two profile in general. Uh, there are two kinds of people. One who are just coming from SQL background, the traditional business intelligence reporting guys, and the second one would be the analytics people who are coming from non-technology background. Both of them would be able to use should be able to use, if they have a small understanding of SQL, they should be able to use Pig and Hive, and that should be good enough for them. A general concept about HDFS, Hadoop, and all of this should be good, and they don't need to code here and there. In case there is a function which is not available in Pig, they will ask Hadoop developer to create that function in Pig UDF, and then these developers will hand over the jar to those guys, and then they can run the analytics. All right. So that's a quick way of looking at the career. Now I'm going back to where we were. We were here, right? And I wanted to know that is my email going to spam by any chance? Okay. Because some people were reporting that the your spam is going into your email is going into spam box. And all right, all right. And I was suspecting that out of 10, 11 people, there are only 4, 5 people right now. And I'm wondering how come that is happening. All right, never mind. So yeah, let's start. So no questions before we start again. All right. Now, so as far as I remember, we were somewhere here. We talked about importing the data into Hive, right? So first approach was take a database table. First we created scoop ex3 and we created widgets and we said import. This basically copied the data from MySQL into your HDFS. All right. And before that, we talked about if you are trying to import the data, you need to first create the database or give this database permission such that all the Hadoop nodes should be able to talk to read the data from your MySQL. All right. In this approach, first we imported data into HDFS. Then we created a table in Hive automatically using Scoop. So this table was created based on the table structure in MySQL. And once the table is created, we simply did load data from this file into this table. That's all. So the data from HDFS got imported into Hive. Now, you must have noticed that these are three steps. First, we copied the data from MySQL to HDFS. Second, we created the table in Hive. And third, importing the data. Third was importing the data from from HDFS into my Hive. So instead of these three steps, you can simply say scoop import and the database properties and say minus minus Hive import. And this will import the data into Hive directly. All right. So I can show you that part. So let me SSH. So let me SSH. Where were we? So if you see in the Hive, All right. Here, let me just import this data into and show table select star from widgets. So it already have data. So let me just drop table widgets. Okay. Now let me just run this and see. It should say the table file already exists or something of that sort. All right. So it has been imported. Now say select star from widgets. So the data has come here in a single shot. All right. Now next step is that we whatever we table we have in MySQL, we want to import that data into HBase. Okay. So if we run this command, it will basically create. Let me go back here and start HBase shell. So what we want to do is we are saying scoop import and HBase create table, connect to this port and give the table name. And here we provide the HBase table name. After that, we say column family CF1 or whatever. Okay. So what would it do is it will take all the columns from this table and put it in a column family called CF1. All right. So if we have scan customer, so we already have this table. So we'll say disable customer drop table customer. Okay, so it has been deleted. Next is that not here on the command prompt. We are trying to do is we are trying to import the data using this scoop into our HBase, where the table name will be customer, and all of the columns will go into a single column family called CF1. All right. So the process is going on. So we are moving data from MySQL to HBase using scoop. Anand's question is, what if we want to create multiple column family with this? Correct, correct. So what you can do is the strategy here is, so let me first show you this. All right, all right, yeah. So I'll show you that. Just a second. So let me answer Anand's question. So Scoop provides you the functionality of importing data, and we say import. Yeah. Here you can provide the column names, right? You can provide, if you see HBase, we say HBase table name, and here we provide column family. And just a minute, here there is a column names. Where is the column names? Yeah, columns. You can see that. So let us say that you want to do only import few columns out of it. Okay. So you say, yikes. All right. So you start saying my column name is A1 and B1. All right. In the next shot, after this is done, also there is an ID column here. And there we have columns E, inline, table, target directory, warehouse directory, check, import. There is Hive, HBase. Yeah, HBase row key. So let me explain to you what I'm trying to do. So Anand's question is, what if you have two column families? Say you what you want at the end of day is a table called customer with column families CF1 and CF2. CF1 contains A column and CF1 contains B column and CF2 contains C column, right? Now these ABC in MySQL, the table contains A, B, and C, and there is an ID also here. Okay. Now based on this, you have to import this table, this MySQL table. Is the font clear? So what you want to do is you want to import this into your customer table here. So in MySQL you have customer and you want to import this into this table with two column families. So how do you do it? So it's a two-step process. It's a two-step process. So first what you do is you import the data with this in column family 1 and you specify that I want to import columns A and B with the row key. Row key you are specifying explicitly that your row key is ID. So ID will go as a row key in this. A and B will go into column family 1. And now you pass the second command. You will pass the second command saying column family 2 and the row key remains the same. And you specify column number C. So this one will basically insert extra rows into the same table with the same row key, and effectively it leads to what we are looking for. So these two commands will do the job of importing data in such a manner that AB would go to CF1 and C will go to CF2. So Anand's question is that it is like alter table, add column and update. So as we discussed while we talked about in case of HBase, the addition of row is similar to addition of column, or addition of column is like you are adding more data, nothing less than that. Okay, it's not an exception or it's not something very different than adding row. Okay, so your table expands both the directions. Therefore be prepared and prepare the mindset that adding columns is not an exceptional thing. It's just like adding rows. All right. So, okay, there was a voice issue was there. So from what do I need to explain? Right. All right. So yeah, I'll be more cautious next time. The moment it breaks, I will try to stop. So sounds good. Sounds good, Anand. I missed one question after. What if it was an API, right? Now, what does it mean? Do you mean to say that using API, can we import the data? I did not get this. Uh, So, yeah, feel free to explain. I would love to listen. I would want to understand the question properly before I answer. REST API. Okay, what if it is an API, REST API? And all right, so let me guess what is your question is. You mean to say that you have a REST API. From there, you want to import data into HBase? Is that your question? So your REST API gives out the data, and that data you want to insert into HBase. All right. So in those cases, you will have to write your own classes which take the data from REST API and move to HBase. Or if you have a connector somewhere which converts that REST API's data into SQL, then you don't need to code. You can simply download it into SQL and then keep on moving to HBase. Make sense? So that is one way to do. Otherwise, you will have to, if you remember our previous session, when we talked about how to programmatically create values, columns, add rows into HBase, then you will have to use the programmatic way. Perfect. All right. Now, next is this is clear. Good. I'm closing this. Now, the reverse of what we are trying to do. So, what we want to do is we want to take our Hive data to MySQL. All right. So, actually, we have just repeated what we have talked earlier, but that is good. So, yeah. Now we have got sales table. Just a second. So, let me go to my folder. And there was Hive, not Hive, there was Scoop. Okay, never mind. So what we want to do is now we have some data in Hive. We want to import it into MySQL. So let's see in Hive, does this table exist? So in Hive, let's just load Hive. All right. So let's say select star from sales dot log, and what was the database? Yeah. So we already have this table called sales in Hive, and we have already created this data. And what we want is we want to take this data to MySQL. We want to take this to MySQL. So do we have MySQL here? All right. So we say use what was the table? Scoop ex3 and select start from sales. Yeah, it's already there. So we'll say drop table and say sales. Okay, because that's what we are trying to import. Now we have this table in SQL, in a Hive. We want to take it to SQL. So we'll just execute this command and that should do the good job. So I'm opening the third command prompt. In one will be MySQL, other will be Hive, and third we will run the scoop command. All right. Now let's just, what are we trying to do? We are saying scoop export. Note it's export because we are standing on the big data side. So any data going from big data to MySQL or relational is export. Any data coming from MySQL or any other database into HDFS, Hive, or HBase is import. So let's take this command and run it. And what does this say? It says export the data lying in this table, in this URL, this table, and the directory is this one. And these, the input fields are this way. Also note that before we create the MySQL, before we export the data into MySQL, you need to first create the table. Okay. Why? Because uh, Scoop is not able to create the table from Hive into MySQL. Why? Because in Hive, not all fields, the table description may not be sufficient enough. All right. So let me just create the table. Okay. So I've created a table. So select star from sales. There's nothing in it. Now let's export the data into this table from the using scoop command line. So basically, HBase tables are in file format. I did not get this. What makes you think that HBase tables are in file format, or do you mean Hive tables? Yeah, yeah. Hive tables are basically the data in Hive is metadata and then supported in by the file system. The data is lying in this. So here we have to tell two things. One, we have to tell that basically, if you look at it closely, we are not really importing data from Hive. We are importing data into, just a second, this is a little bit of an embarrassment. And yeah, so yes, Hive tables are in the uh, command prompt in the file system, and that is you are right in that. If you see, we are using this folder, we are using this folder to export the data. Make sense? All right. Now let me just go back here and say select star from sales. So now the table is created with the fresh data. Okay, using this command. All right, so that was multiple things we did. We imported data all from Hive to MySQL. So we basically did these many things. Okay, so window, share, capture tools, capture. So we did these many things. On one side we had HDFS, Hive, HBase, and other side we had MySQL. And so you can think of it HDFS, Hive, HBase. So what we first did was and this side is our MySQL. Okay. So first thing we did was we took the data from MySQL into HDFS, then we took it to Hive, then we took it to HBase, and once we were done with that, we took the data from Hive back to MySQL. Okay. The other ones are also completely similar, taking from HDFS or from HDFS and Hive, it's the same story. Okay, from HDFS and Hive, it's the same story. And from HBase is something you can have a look at it. It's not a big deal. Okay. All right. Now let's talk about something little different from what we have so far learned. Whatever we learned, except for Zookeeper, there was parallel, some parallel system in the normal world. Here is the Flume does not generally have a parallel system because the problems the Flume is solving is very much related to unstructured data and huge volume of data. So Flume is essentially a distributed, reliable, and highly available system for efficiently gathering the uh, the logs or the unstructured data from various sources. Okay. Whenever we say unstructured, it generally means that we don't know much about the format of the data. It's not like relational data. Okay. So that's what Flume is. Or in very, very simple words, you can use Flume for single directional data transfer. For example, you are downloading data from Twitter that can be done using Flume, or you are downloading logs from your web servers. If you have 10 web servers and you are copying these logs to a central machine. Okay. And that's where the Flume comes into play. So Flume has got this very generic structure. So ideally, what people could have done to build Flume-like services, there is one customizable connector from every source to every destination. Okay, and that should be it. But Flume goes to a next level and breaks down the monolith client. So when I say monolith client, if you guys have been using some sort of a backup system, you install the client and that's it. Okay. Here you install client Flume agent, or you can say agent. You install the agent, but you do few more things. While you can design your agent really modularly. Okay. So all the machines from which you want to pull the data, you install the agent on all those machines. And what is an agent? Agent is essentially made up of three components. Okay. It has source, it has sink, and it has channel. Source, sink, and a channel. data from. So in the monolith systems, what happens is that there is only one entity. There is only one entity reading data from that machine and sending it to HDFS, right? There is no customer. There is no components in that. Those are the systems which are not modular in nature. But Flume goes to a next level, and every node contains three things: source, sink, and channel. And each of these parts can be configured differently. Okay. If you, how many of you know the problem of producer and consumer? Has anybody been to a producer consumer problem? Sergio? Okay. Mark? All right. So a producer consumer problem is a typical problem which is discussed whenever we discuss synchronization or threads. So producer is somebody who produces data. Consumer is somebody who consumes the data. In case producer is not producing, consumer waits. And in case consumer is slow at consuming, producer waits. Okay. So this is the general philosophy of producer consumer. To build, if you are able to successfully build a producer consumer, then you will be able to handle every synchronization issue. Or if you get a little bit of a time, there is a problem called dining philosopher problem. Okay. Yeah. So there basically, let's come back to the producer problem. You can have the dining philosopher problem, right? Now here the problem is, in case this web server is producing data at very fast pace, and the sync, the rate at which you are writing to the disk, is slow. So web server is producing data 1 kilobyte per second, okay, while your the way the data is being written is around 300 MB per minute. Okay, so the frequency of data production and data being saved to the disk is different, right? So there is a disconnect. So you create a pipe instead of the source and sink being waiting on each other and delaying everything. So they will create a pipe in between. Source will keep on filling this pipe while sink will keep on cleaning the pipe, consuming the data from pipe and putting it into HDFS, right? So the difference, so here sink consumes a lot of data but at a very different frequency. So sync is like hard disk writer, somebody who's writing to hard disk every minute. So every minute it can write MBs of data. Well, on the source side, it's producing a lot of data. Now imagine that there was no pipe. So if for each KB, the source will wait for sync to finish, and hence web server will be hurt, in the sense that when the logs are being consumed from the web server, web server might have to wait. Okay, so to avoid those kind of circumstances, a pipe between source and sink is created. Producer and consumers, rather than talking hand in hand, meaning producer giving the production in the hands of the consumer, production puts it in the pipe. Okay, or you can think of it as a what do you call that, the on the airport there is this chain which is continuously moving. What do you call this? It's called the I'm just missing that word. Conveyor belt, right? So you can think of as if source is keeping this stuff on conveyor belt, and sync is slow but it consumes a lot of data in a single shot. All right. So that difference between frequency of consumption and production is being overcome by the use of a channel. Make sense? Thank you, Santana. And yeah, here that is the main reasoning behind having channel. Other is there could be multitude of sources and multitude of sinks. If you have 10 different type of sources and 10 different types of sink, total number of agents that you can produce with this is 100. So there could be 100 possible combinations which it can cater to. All right, 10 into 10. While coding 20 coding 20 things, as in writing 20 connectors, meaning 10 readers, 10 sources and 10 sinks, is easier than coding 100 components, right? So that is why the modularity matters a lot. So now you understand why this kind of design. So imagine web server is giving a lot of data. Your agent will consume the data, push it to HDFS by the way of using these three things. All right. The sources could be a wide variety. A source could be tail minus f, meaning how many of you know tail minus f? What does tail minus f do? Nobody? Perfect. Perfect. Yes. When the data is being written to a file continuously by somebody and you want to keep on reading as and when data is coming into the file, you use tail minus f and then file name. All right. So it becomes like a stream way of generating data which is coming to a file. So a tail minus f is a valid source to your Flume applications. Syslog is another. Syslog is your Unix syslog, system logs, where system logs are being generated parallelly. And similar is your log4j, and there could be multitude of sources which are supported. You can create your own source by the way of extending one class, and that's it. All right. Now, the other important aspect of Flume is that you could arrange these things in a very, very complex fashion. A channel can give the data to multiple sinks, or multiple sinks can read from a channel. Similarly, there could be multiple sources which push the data into the same channel, and so on, right? So by connecting sources and sinks in a complex manner, you can create really, really powerful pipelines of the data. And this way, this structure of creating the log pushing system is really, really powerful. All right. So let's go through one small exercise where, so Anand's question is, this may not be relevant, but can we gather data from multiple databases through Flume? Not really, not really. But through Scoop you can. In real time, that would be an issue with Scoop, because Scoop would be, every time you run it, you'll have to run it again and again. But you can define that this is my ID qualifier, do it only for the newer records. Okay. So it will basically figure out by itself that which all IDs have been pushed already and will not do it. But you'll have to execute it again and again. Yeah. So you are right. In that sense, if you have to gather the data from multiple databases through Flume, you can essentially create your own source, customize the source such that the data you keep on reading from MySQL or any database is pushed to the destination. Okay, you can do that definitely. Okay, so as of now, they don't provide the source for MySQL, but I'm not sure. They might have started now. Now let's go to what we are trying to achieve. Okay, so let's have a look at what it is. Here you have got one agent called A1. This agent has got three components: one source, one sink, and one channel. As you can see, you can define multiple sources and multiple sinks here by putting comma. Next is we define the meaning of the source. So we say that r1.type is netcat, r1.bind is localhost, and r1.port is this. What does it mean? It will essentially start a service on this machine at localhost at this particular port. Okay, and which effectively means the agent has been started on the machine and is waiting for services to push data onto this. Okay, so netcat is that kind of a type which basically starts a service here. Next is the sink. Sink S1 has got a type HDFS, which means whatever you dump to the sink, which will go to HDFS in this particular folder, in this folder. All right. Now let's go to this folder once and have a look at what's going on there. So we can say Hadoop 8000, and can we just directly go there? So here there is already a file. We can delete this file. Okay. Next is we create a channel. This channel will always be in the memory and its capacity is this much. If the channel's capacity exceeds, then source will have to wait before writing the data. Okay. If channel becomes empty, the sink will wait till something comes into the channel. So it's a standard producer consumer paradigm. The problem is solved by the use of a pipe. By the use of a pipe, the problem of producer and consumer is solved. And that is probably the best solution to producer consumer problem when it comes to synchronization. Next is we bind them. We tell the source that your channel name is C1. We tell the sink that your channel name is C1. Okay, and this way, once it is done, we can load using this command. That we can say that here we are saying that my config folder is conf. In conf there is a lib folder. If you want to add your sources, all you need to do is create the jar of your source, put it in the conf/lib, and you can launch your own source or destination or sink. Okay, now we are here. Okay, it would give an error saying the Flume is not able to find the properties. Yeah, here it is. All right. So the source has been started at for here. Now we can connect and dump the data in that particular folder. So sorry, we can say telnet localhost and 44. So we are now connected to the source. Whatever we write here, whatever we write here is being written at HDFS. Okay. This is something that would go to HDFS. Okay, and this is continuously happening. Okay, so we're continuously writing, and here in this folder, if you refresh it, you will see it. You can see that this is something that would go into HDFS. Oh, I wrote HDFC. Okay, and is continuously happening. Now you can understand the reason why this is so nice and popular. Okay, if you refresh it, you will see the data. Go back. Now one file has finished and next file is here. You can see that. First line says that the data is in the format called bytes writable. And you can specify bytes writable and get the data in the bytes format. Okay, sounds good. Alright. So this was a very quick introduction to Flume, and this should give you an enough information about how to push the data. What if we have multiple sources? Will the data be jumbled? No, the data will be very properly structured. Okay, you mean to say, imagine that for time being, let me just do a little bit of treachery here and try to do few things. Okay, so I'll just say quit. And how do you quit? Oh, my connection is just gone. Here, I've actually closed that connection. All right. Now, in the here, you have Flume. Okay. So if we say now again, if we say copy conf to conf1, and we simply in the conf1, we simply just give me a second. Yeah. So let me, yeah, interesting questions. Will the data be jumbled? Answer is no, because that's what it is supposed to do. If you have log files from different servers, all of that will be in a really good format and always consumable. Okay. What is the significance of streaming this info into real world? what is the significance of streaming this info into real world? Okay, so yeah, significance of streaming is that say you built a system which has to continuously get the data from Twitter, as and when people are talking about the campaign you are running, you are getting this data in real time from Twitter and you're pushing it into HDFS. So that is the significance of the real time in this case. Okay. Anand's question is okay. I think Anand was trying to answer. All right. Sounds good to you. All right. Similarly, you can actually run the conf1 and two servers on two different ports, listening to two different ports, and then writing to the same file. It will still be perfectly okay. And that is why you see here, why would it be okay? Because everyone will create different files in this folder. If you have 1,000 writers, there will be 1,000 different files. All right. Now moving on. So this was our quick introduction to Flume. Next is your Oozie. Oozie is a workflow scheduler system to manage Hadoop jobs. Okay. Yes. So it does two things. It has something called a coordinator, which behaves like cron job. Not only cron job, it also provides a way of monitoring a folder or HDFS file in order to launch something. Okay. It's on not only time based but also data based. Sounds good. And it is very well integrated with the whole ecosystem of Hadoop. Now imagine this, you have got have you guys used Make, Ant, or Maven? Have you used that? Any of that? Make, Ant, or Maven? Great, great. If you guys have used Ant or Maven or any of these systems, old Make system, Make install, Make build, and all of that, all of them have one thing in common. They tie the various commands together in order to build your project, right? Similar is Oozie. Oozie is fairly scalable, reliable, and extensible, and is very well integrated with the rest of the Hadoop stack. Okay. Actually, what would I do is I would like to take up Oozie tomorrow, and right now we'll go ahead with Mahat. What do you say? Okay. Ideally, Oozie should be discussed at the last. So in future sessions, I'll move Oozie to the last one, and then we'll talk about. Before that, we'll talk about something else. Okay, make sense? All right. So I want to discuss something called Mahat. And before, yeah. So how many of you understand what does it mean by scalable machine learning library? Or what do you mean by machine learning? Anyone? Okay, Anand is not sure. And all right. So I'll show you a video. I'll show you a video that will probably uh, remind you your old days as well. Have you played a game called Mario? Great. So I'm going to play this video, and probably this is best way to understand what is machine learning. Okay. So what this guy did was it made the computer learn automatically any video game. Okay. Any video game, be it Mario, be it other, what he did was he he wrote he used a machine learning algorithm and told this algorithm that keep an eye on the score, try to maximize the score, and figure out which keys to press by yourself. Okay, press all kinds of combination of key, learn from past experience, and maximize the score. That's all he told this program to learn from, to basically learn from its own mistakes, and the objective is to play the game. So the computer will be playing the game. All right, here here it starts playing the game. So this is the first shot. This is like a small baby playing, right? Not this one. So yeah. So here, if you remember this, we used to play this. Here he himself is playing it. And later on, what he has done is, yeah, this is where the program starts to play this game. You see, it's doing nothing. It's just trying to figure out what's the score, and it's doing nothing. He just keeps on jumping here and does nothing and dies of old age. Now, it's trying to move a little bit. It's trying to move a little bit, and it doesn't know what's doing. So it's a computer playing this game, and it's playing by itself. Again, it died of old age. This time, it has figured out that if it hits these things, then it'll get the score. Again, it starts, and again, if it jumps on Goomba, then it makes the okay. So you can see that. So it automatically is figuring out based on the numbers, based on the memory state of the game, that what is it that earns him the points. Now you can see it's playing pretty good after 24 hours of training and learning by itself. For some reason, it just jumped into this. Now, the next thing, what happens is something which will surprise you. Okay, which will surprise you really nicely. Now see, it's playing really good, really brilliantly. It reached to this level. It's just that it's not using. Oh, it found out the technique also. So it basically automatically learned, and here it got stuck. and maybe he'll die of an old age here. He's trying to figure out where to go. Now he modified the code a little bit, tweaked that algorithm a bit, and now if you see, it has just perfected the art of playing Mario all by itself. We did not have to code anything. We did not have to write a single line. He did not have to write a single line of code specifically for Mario. All he did was just used a machine learning algorithm, trained it well by itself. It also gave it a way, or see if it's playing so beautifully. And yeah, after 24 hours, this is the status of his learning. So program learned to play the game by itself. All right. Now this is next level now. Again, now something would happen that would actually surprise you here. Look at this state. Look at that. It actually hits the Goomba. It actually hits the Goomba and kills it. How did it do is it figured out the bug in the Mario game that in case Goomba is coming from above and you start moving downwards, then you actually make it look like you are hitting the Goomba. Sounds good. Now he also trained it on another games such as this one and so on. Okay. And something which it did was surprising to them and everybody, that when it has nothing, no step left, nothing to win, then all it did was paused the game. Okay? Because if it unpauses, it will lose, and therefore it paused the game. Just like our cousins in the childhood, when they lose the game, they just throw away our carom board and run away because they did not want to lose. Similarly, this game also grew to that, this program, this machine learning algorithm also grew to that level of intelligence that it can pause the game. So, all right. So this is the heights of machine learning as we are today. Did it make sense to you? So that basically tells you this researcher did not do much. He did not write machine learning algorithm. He did not write anything specific to Mario. He just utilized existing algorithm. He just utilized existing algorithm for the training and fed the data automatically from the Mario emulator. Yeah. So does that give you a sense of what does it mean by machine learning? Mark? Awesome. So yeah. So basically, now all these words would make more sense to you. So you can train the computer to understand data by itself. You can tell the computer that this email is a spam and this email is not a spam. Yes, that is correct, Santana. So there are lots and lots of use case of machine learning at a various level. Machine learning is just like the human kind of thing. And so there will be infinitely many use cases. We will talk about few handful of the use case where it's being used currently, and there are millions of more use cases. Okay. So, and good news for the people who are not researcher is that they can just take the things out of the box and start training it or start using it right away. Okay, and that's where the role of Mahat comes into play. Mahat is collection of such library which does the machine learning for you. You don't have to write a single line of code in order to do the machine learning. Okay, all you need to do is tie your input data into Mahat's algorithm, and Mahat will give you the predictions. All right. Now, Mahat is based on name of Mahat comes from an Indian name for the keeper of elephant, and because it used to run only on Hadoop, that is why it was named as Mahat. Mahat is somebody who drives the elephant or keeps the elephant. Similarly, it used to run on Hadoop, but now it is also being ported to other platforms such as Spark. Okay, the formal definition of machine learning would be programming computers to optimize performance using example data, or you can say past experience. Okay, so the easiest one where we use the past experience for the prediction was graph plotting. If you remember, we used to have the data which we plot on the graph, and then we do the extrapolation. That is prediction. In the most simple and primitive format, extrapolation after plotting a graph is is the most trivial form of machine learning. Okay, so computers basically evolve behavior. As we saw just now, evolve the behavior of learning to play Mario based on empirical data. Okay, empirical data. We did not tell it that there is a 2D space. We did not tell it that you can jump and there are things like Goomba which eat you. We did not tell any of that. It figured out by itself, just based on empirical data. What was empirical data? The memory state of the memory of this game, memory state of the game, which was fed to it continuously, and it figured out based on that memory state. All right. There are different kind of machine learning. First one is supervised, where you have clearly labeled data, such as email. You have clearly labeled that this email is spam, this is not spam. If you are building a spam filter, you are basically doing a supervised learning. Okay, that is called supervised learning. You know what is good, you know what is bad, and you train the algorithm that by feeding this data, this is good, this is good, this is good, this is bad, that is bad, and so on. That you train your algorithm by this kind of input, and once that is done, you start asking it, is this good, is this good, and then algorithm will, based on the past experience, will start telling you. Next is the unsupervised learning. Unsupervised learning is clustering. Okay, you have got unlabeled data. Okay, you have got completely no clue about the data, and you say, based on these emails, can you just categorize these emails on in 5 different piles, in 5 different sets? Can you just categorize these emails? That is an unsupervised learning. You did not provide any information other than the email content. Other than the email content, you did not provide anything else, and that is called unsupervised learning. Next is semi-supervised learning. For some records, you have some information. For other records, you have no clue. In those cases, you use the part of machine learning called semi-supervised learning. These are only few handful examples of machine learning. Machine learning is an area that has got a lot of implication now, and the reason is big data. Why? Because for the machine learning to do anything, it has to gather a lot of data. Only then it makes sense. If you do not have more than 10,000 vectors, this game, the Mario game, was played by the computer for more than 24 hours to get the perfection. And in those 24 hours, computer played the game thousands of times. It played the game thousands of times and gathering lo- each vector, each state information, that every millisecond state of the memory was was the data. Okay, so that is why whenever you are talking about machine learning, you always talk about humongous data. Reason being, the more the data, the better it gets. Okay, the more the data, the better it gets, because the in another word you can say, you can plot a better graph if you have more data. If you want to if you want to find a correlation between, say if you have got a million variables and you want to find the correlation between them, if you have you cannot find the correlation between a million variable unless you have at least 1 million data points. All right, so that is the reason machine learning and big data go hand in hand. Okay, few examples you would see in day-to-day life is recommending friends, days, products to the end user, classify content into predefined groups. Okay, such as spam or not spam, is it update or is it something else? So those are predefined groups. Finding similar content based on object properties. You must have seen in Amazon. You must have seen in the Amazon that in Amazon, when you have an object, you can say that there are multiple objects like this, right? You may also like this object if you like this. Given a collection of text, machine learning algorithms can find the key topics, detect anomalies in the dataset, ranking search results with user feedback learning. Based on users' behavior, it will start to figure out which results to keep and which results not to keep. For example, say you are building a magazine and you don't know what does your user like. So based on the user's behavior, you will try to figure out what is it that user likes and doesn't like, and accordingly prioritize the articles in the magazine for that particular user. Okay, all right. So there are many different kind of applications, including computer vision, natural language processing, biometrics, speech and handwriting recognition. Okay, for example, if you are building an handwriting recognition system, all you will do is you will keep on writing alphabet a million times and keep on telling this algorithm, this is a, this is a, this is a. And after point of time, you will write a and you'll ask, what is this? And this algorithm will tell you that this is a. All right? Yeah. So machine learning could be based on normal statistical ways or it could be based on neural networks. Okay? Machine learning can be done in multiple ways. Neural network is just one way of forming the correlation between input and output. There are multiple ways of forming correlation between input and output. And yeah, all right. Now, what kind of tools do you generally use for machine learning? If you have got few 10 lines or 20 lines, you will basically use your whiteboard to draw the conclusion, right? If you have just 10 points, you will draw it on whiteboard and say, oh, after 10 years we'll have this much of revenue, or next year probably this is going to be our revenue. Just plot the graph and you will get the output. But when the data starts growing and you want to do more predictions, you might want to use R, MATLAB, Octave, or or other languages. Okay. But when the data starts reaching GBs, meaning say 500 MB or half GB or 1 GB or 9 GB or till few few GBs, then the problem starts. And then you have different tools for analysis and visualization. For analysis, you start using SciPy or NumPy or these tools. But when the data grows in TBs or upper GBs, as in 500 GBs, then none of the existing tools would come into the rescue, and that's where the role of Mahout, Giraffe, or MLlib comes into play. This kind of data could only be handled using a distributed system. This kind of data cannot be handled when it comes to machine learning using existing tools. Why? Because most of these algorithms are extremely complex. What does it mean by complex? Complex means very time consuming. Okay. Now we will walk you through an example of Mahat. We will generate the recommendation using Mahat. The recommendation is again a sort of a machine learning, a sort of predictions. So all we will feed Mahat is these three columns. First column is person. Second column is which movie they like, and what is the rating. We are not going to tell Mahat anything about the user or anything else about movie. We are going to just feed these three columns, and Mahat is going to give us the recommendation for these users. Okay? And how would it do that? It basically will compute which users are similar to each other, and if the user is very similar to each other, give start doing the cross recommendation. I- You say that start doing the cross recommendation, meaning if Sandeep and Kumar are very similar, 10 5 out of total 10 movies, or 5 out of total 6 movies are common in these two guys. That means we can start giving recommendations to these people. Each other's extra movies you can start recommending, right? So here we are going to use, there are multiple algorithms. What I just told you is called Tanimoto coefficient, where we have we try to find similarity index between the two users, ba- and the similarity index is the common movies divided by total movies. So if I have watched 3 movies, you have watched 5 movies, and we have one movie in common, that means it is 1 divided by 5 plus 3 minus 1, which is 7. So our commonality is 1 by 7. All right. So we'll use this one. The important part which you need to understand is the actual algorithm is to execute the actual algorithm is far, far, far simpler than getting the data into shape. Okay, so let me just move to the next session. Are you with me? All right. So here, first, what is it that we are going to do? We will download this file ml dot dash 1m zip. We are going to unzip it, and then we will have to prepare a CSV file. CSV file is what is accepted by Mahat. CSV means comma separated file. User ID, comma movie ID, comma rating. This is the kind of format Mahat is accepting for as the input data. All right, but our data is in a double column separated, so we'll have to format the data and then send it to Mahat. Okay, so yeah, so before we take the break, we'll just start this process and see what all could be done here. Let me close Flume. Flume is closed. Now next thing is wget this file, and there we go. Okay, so go to asgiri folder, not here, we say asgiri, and here it says it's already there, not retrieving. And then you say unzip minus update minus u. It probably updates the existing extracted one. It says it's already there, so you can see the folder here. We already have the rating folder. Okay, now let's peek into what is inside ratings.dat. So our ratings.dat has user ID, movie ID, and the rating. And there is a timestamp. We don't require this. We only require these three fields, that too comma separated. So can you recommend a way which is the good for this? Anyone? We want to convert this into ratings.csv. Oh, we don't have ratings.csv here. Hadoop fs minus cat asgiri ratings.csv. Now this is what we want to convert it into. Okay. So Anand is saying replace double colon with comma. And how would you replace? What tool are you going to use for that? Okay, good. So we'll just use the Linux command. That's what Anand is saying. But in case the data is really humongous, what is it that you should be doing? Yeah. Anyone? If the data is really huge, do you think we can use pig for this? Remember, we loaded the comma separated data into pig. but using pig storage. Similarly, we can also load this data into pig using colon, and then we can simply say store only these columns. Make sense? We can say for each and then generate only those columns which we want, and then we can store that result set into somewhere, right? So, but here we will just do it using our command, Unix command, where awk is there, awk minus f, the fields are there, $1, $2, $3, and what it's going to do is it is basically going to read this data, okay? Is basically read this data, give it to awk. Awk will split it by double colon, and then it will only print first, to second, and third field, that two comma separated, and will generate ratings.csv. Okay. Now you can see that ratings.csv has got those records. This is an inefficient method. Pig will be better if the data is beyond few GB. Okay. Pig will be better than this approach. Now once you're done, let's copy it, Hadoop fs, and then we say copy from local and ratings.csv and into asgiri folder. Okay. So -f basically ignores that error and tries to upload. So we have uploaded the ratings.csv into asgiri folder. The next thing you need to do is remove the tmp directory from the home, rm-rf, rm-rf, and there will be, oh, it's not there, hadoop fs-ls. So here, yeah, this tmp folder we need to delete because it was created by, all right, and after that, yeah, there was one more thing. All right, now next is that we are going to we copied the data into our asgiri folder. Next we have to set up this java home path, and after that we are going to run the recommendation. Here we are saying please run the recommendation algorithm, recommendation at the library, and in that library use this particular algorithm for similarity. Okay, there are multiple kind of algorithms, and save it here. So I will delete that folder also. What was the name of the folder? asgiri.recos. Okay, now let us run mahot command. Okay, so we did couple of steps here. First we downloaded the data, then we unzipped it, then we extracted only three fields that and converted into comma separated. Next is we copied the file into HDFS, and after that, after we have set the Java home path, because Java home is required by anything which runs Java, and we executed our Mahot algorithm. Mahot will internally be calling Hadoop right? Here you can see that it has internally launched a service. You can see that here. You can go to this URL and then you can run it. It is showing that it is preparing something. So one map, one reduce. There will be multiple phases of various jobs. All right. So this will essentially, after the work is over, it will generate the rate recommendation for each user. This is the user ID. This is the recommendation item, and this is how much it is recommended. Okay. For 6029, it has recommended these three or more items, and this is how much it has been recommended. Okay. And you can see that it is a folder, and the part is basically looks like that this is MapReduce only. Okay, sounds good to you? All right, so let's take a break for 10-15 minutes and then we'll start again. Take a break. I'll need 15 minutes break today. All right, we will be back by 10:25 p.m. Uh, Hi, I'm back. Can you hear me clearly? Should we start now? All right, so I think it has finished successfully. It has finished and it has taken 11 minutes to run. That is too many milliseconds. And this has taken 11 minutes on how many? Four nodes, multiple phases actually. And the output would be in this folder as Giri Records. Okay, so you can see Hadoop fs minus ls as Giri Records. All right, so there is only one part Hadoop fs minus cat. So this is the recommendation. So for user with the ID 1, these are the recommendations. All right. So basically, you created this brilliant set of recommendations for the users, and now what would you do is you take this data, push it back into your MySQL server, and on your J2EE server, you will start displaying this as the recommendation to your user. Okay, make sense? All right. So this is how the this is how you generate the recommendations. So on one hand, it's a very great news that you can straight away out of the box, you can start using Mahat. The only effort that would go from your side would be in the preparing the data that becomes the input to Mahat. Okay, there could be multiple kind of challenges. First, figuring out first would be figuring out how to compute the ratings. Okay, because ratings will not be provided to you just like that. You know there is a user, you know there is a product. If you have to do the same thing for products, that people who like this also like this, or you may also like these items based on your past history, you might have to take into consideration various aspects. First, the products you bought. Second, the products you might have added in your favorite list. The products you have been viewing again and again on the website. So you generally form various kinds of ratings for each of these factors. Okay, you basically deduce the ratings. All right. For example, when I was building a recommender for InMobi, what I did there was based on Apache logs, I created the recommendation. Okay. And for those who do not know what InMobi does, InMobi shows you the ads while you play the game. If you play a mobile game, chances are that you will see at least once the ad given by InMobi. Now, when you're playing the game, at the bottom there is a place allocated for ads, maybe at the bottom, maybe at the top. eh, Okay, so there is a place allocated for the ads that is nothing but a browser. This browser hits the web service and also tell the web service of InMobi that User was playing this game when he requested for an ad. When the browser requested for the ad, this particular game was being played. Now, based on this history of the user, that app continuously we have seen continuously back to back in last 1 hour, there has been 10 requests from the user, and every time this person was playing Temple Run, which means this person really likes Temple Run. All right. Yes, multiple data files can be analyzed. The input file can also be an input folder. All right. So basically, the maximum amount of work will go into preparation of the data. All right. The complexity of algorithm is fairly hidden to you, and you can play agnostic to the algorithm. Okay. All you need to understand is which algorithm works better in what scenarios. Okay. There are multiple algorithms in Mahat. These are the multiple algorithms just for recommendation. Okay. I've used Tanimoto coefficient, and here we use log likelihood, and similarly we can replace this command and say any of those algorithms, and you'll get the results. Which slide? A mark here. One more. This one. So this is the command Mahat recommend item based minus s, the algorithm you're passing, the input data and output data. Okay. And here is the output. Now there are a few things you should note. First is preparation of the rating, that you have to bring it down to something like 5, something between 5, which means you'll have to do the normalization. Second is the item has to be converted into a long. Long is a big number. So whether your item is a string or hexadecimal number, you have to convert it into you have to convert that item to a long. Similarly, the user ID also has to be converted into long. Okay. And that again becomes an interesting big data problem in various scenarios. Okay. So if you follow my blog, okay. So here is my blog, and in this is a small case study where I have demonstrated that how tricky it gets when the data becomes when you have to cleanse your data and prepare it for Mahat. Okay, so you can have a look at this. This is a common challenge probably everybody would face. And how does various techniques play a role? All right. And you can also give recommendation that this is how you could have solved this problem instead of this way. I know at least two better solution than this. Okay. All right. So these things we have already discussed. So that's pretty much about Mahat. So there are This was collaborative filtering. You can do the clustering. Clustering is takes item in a particular class, such as web pages or newspaper articles, and organize them into naturally occurring groups. Okay, and the classification, existing categorization. It learns from existing categorization and then assigns unclassified items a category. Okay, and then fourth class of problems which Mahat solves is frequent item set mining. Okay, so it basically based on the past history of items which are being sold together, it starts grouping items together. That is free. Okay, any questions here? No questions. The algorithms that is recommended are predefined in Mahat. Can we make changes in it to suit our needs? Yeah. So basically, these algorithms provide you the parameters to tweak these algorithms. Okay. They provide you the parameters to tweak, and in case an algorithm is not suiting you, then you might have to extend an existing library and create your own algorithm and then run it. Right. So these all algorithms provide you the configuration properties which you can tweak. All right. Any other questions? All right. All right. So we will quickly go over Uzi and then we will start with Spark. Sounds good? Okay. So yeah, we discussed about Uzi. Uzi is essentially is comprised of two parts. Given a full workflow saying first run scoop, then first run flume, then run pig, then run mahoth, and after mahoth has finished, then run scoop to push this data to MySQL, and that's it. Okay, so this is a workflow. This is a workflow. A workflow is essentially a directed acyclic graph. We'll talk about directed acyclic graph in a minute. So each workflow job is a directed acyclic graph of action, and coordinator is like a cron job which executes a workflow at a particular frequency or when the data is available. Okay. So what is a DAG? So a DAG is a directed acyclic graph, meaning there are no cycles in the graph and every edge is directional. So edge means the arrows, the lines you see, and the node is the circle, the ellipse. Now, do you think there is a cycle in this diagram? Do you think there is a cycle somewhere? Anybody? Correct. There is no cycle, though it looks like there is a cycle. All right. So here it shows that to finish the fifth task, you need to first finish 11, and to finish 11, you need to finish 10th, and you need to finish 2, and you need to finish 9. And to finish 10, you don't need anything else. So out of this, if you have to execute fifth, first you have to finish the execution of 10, 2, and 9, and after that you finish the execution of 11 and then 5. Okay. This is called topological sorting. Topological sorting means what things should come first and what things should come last is decided based on the dependency graph. Okay, that is called topological sorting. All right, say I have to get ready for the office in and given all kind of dependencies starting from getting up. Okay, so to get ready for office, I need to wear my formal clothes. To wear my formal clothes, I need to take bath, and to take bath, I need to do, get up first, right? Now, so this is my directed acyclic graph. And when you traverse this graph, you will generate the topological sorting. And a topological sorting essentially means the order of way things should be done. So the first element in the topological sorting would be take bath, or sorry, get up. Get up would be the first thing. Then you take bath. Then you after taking bath you wear the clothes and then you go to office. Okay. So that is what we call a directed acyclic. This is a general concept. It's a very useful concept in computing. Every project plan is essentially a directed acyclic graph. So every task or a group of tasks in OOSI, the workflow is a directed acyclic graph. All right. So bear with me. And can you see can you see it clearly here? All right. Here you have a look. This is how your map reduce workflow would look like. In the XML, every workflow is designed in an XML, just like the end tasks. All right. Looks like the net connection is gone.